All right, here is the quotient rule for exponents. And when you are dividing exponents of like bases, what you do is subtract. So for MADS, the D and the S means when you divide exponents of like bases, you're going to subtract. All right, so 5 to the 8th over 5 to the 6th, we're going to subtract those exponents. 5 to the 8 minus 6 would be 5 squared, and 5 squared is 25. All right, 4 to the 2nd over 4 to the 9th. All right, so now there are two ways you can look at this. The way I like to do it is your larger exponent determines where you will do your subtraction. So I can't take 9 from 2, but I can take 2 from 9. So I'm going to write this as 1 over 4 to the 9 minus 2, which would be 1 over 4 to the 7th. 4 to the 7th, that would be a really big number, so I'll just leave that as 1 over 4 to the 7th. All right, x to the 5th over x cubed, that would be x to the 5 minus 3, which is x squared. All right, but if I had x cubed over x to the 5th, the larger exponent will determine where to put it. So I'm going to write this as 1 over x to the 5 minus 3, which would be 1 over x squared. Okay, you could also look at this in this way. All right, if I do it as x to the 3 minus 5, that is x to the negative 2nd, which I would then have to flip and make it 1 over x squared. So you just save a step by subtracting where you have the larger exponent. All right, part E, 5 to the negative 3rd over 5 to the negative 7th. You can flip them and make it positive first and then do your subtraction, which is what I would do. So make it 5 to the 7th over 5 to the 3rd. 5 to the 7 minus 3 is 5 to the 4th. And 5 to the 4th is 625. Q to the 5th over Q to the negative 3rd. Again, I would first flip your negative exponent. So that would be Q to the 5th, and I'm going to bring Q to the 3rd up to the numerator. And now you would use the product rule. Q to the 5 plus 3 is Q to the 8th. So recall MADS, when you're multiplying, you add. So that would be Q to the 5 plus 3, or Q to the 8th. All right, 3 squared x to the 5th over 3 to the 4th x to the 3rd. All right, we're subtracting where we have the larger exponent. So you'd end up with 3 to the 4 minus 2 in the denominator and x to the 5 minus 3 in the numerator. So x squared over 3 squared, and 3 squared is 9. So x squared over 9. All right, m plus n to the negative 2nd power over m plus n to the negative 4th power. I would first flip to make the exponents positive. So m plus n to the positive 4th power over the quantity m plus n to the 2nd power. So that would be the quantity m plus n to the 4 minus 2, or m plus n quantity squared. And you can just leave it as m plus n quantity squared. The only way to simplify that further would be to do m plus n times m plus n and then FOIL, but you can stop here. All right, 7x to the negative third y squared over 2 to the negative first x squared y to the negative fifth. I would first flip everything that you need to flip to make those exponents positive. So I would flip that one, this one, and that one. The 7 y squared and then the x squared in the denominator would stay where they are. So let's rewrite this with everything we need to flip flipped. So that would be 7 times 2 to the positive first, y squared and y to the fifth, over x squared stays where it is, and x to the positive third comes down. So now we're going to multiply 7 times 2, and that's 14. Y squared times y to the fifth, you would add those exponents, y to the seventh, over x to the fifth, because again, we add the exponents. All right, let's try one more. 5a to the negative fifth, b to the third, over negative 3 to the negative second, a to the fourth, b to the negative second. All right, so let's circle what we're going to flip. We're going to flip this a to the negative fifth, negative 3 to the negative second, and b to the negative second. All right, so what is left in the numerator? All right, so I will have a 5. I'm going to flip up this negative 3 to the negative second. Now it's going to be a negative 3 to the positive second. And I'm also going to keep b cubed where it is, but flip up b to the second. And then in the denominator, a to the fourth will stay where it is, but I'm going to flip down a to the positive fifth. All right, so now we'll multiply. This negative exponent only applies to the 3 and not the negative. So that's going to end up being a negative 9. So 5 times a negative 9, b to the fifth, and a to the ninth would equal a negative 45 b to the fifth over a to the ninth. Now that would be different if this negative were in parentheses, then of course that would be a positive 9 and this would be a positive 45. All right, so example 5, we are now using a combination of rules. All right, so we're going to do power raised to a power, the power rule, and the quotient rule. All right, so let's start with this power raised to a power. 4 to the 2 times 3 would be 4 to the 6. Whenever you have a power raised to a power, you multiply over 4 to the fifth. Now we're going to use the quotient rule. So 4 to the 6 minus 5 would be 4 to the first, or just 4. X squared times x to the negative 6 times x to the negative first. I'm going to circle what would need to be flipped to the denominator, and that would be x to the negative 6 and x to the negative first. So x squared stays in the numerator, and I'm going to flip down and make this x to the 6, x to the first. Now I need to use the product rule for x to the 6, x to the first, and add those exponents. So that would be x squared over x to the 7th. And then I'll use the quotient rule. Larger exponent tells me this is going to be 1 over x to the 7 minus 2, 1 over x to the 5th. All right, part C. 2x and this whole quantity is cubed. 2x and this whole quantity is squared. So since the bases are the same, I'm going to keep the same base and add the exponent, so that would be 2x quantity to the fifth, and then I'll raise each thing to the fifth power. 2 to the fifth power is 32x to the fifth. Okay, 2x cubed over 5, and this whole fraction is raised to the negative fourth power. So the first thing I want to do is flip the whole fraction and raise it to the positive fourth power. So 5 over 2x cubed, and that is to the positive fourth power. And then everything inside the parentheses will be raised to the fourth power. So 5 to the fourth power is 625. 2 to the fourth power is 16. And a power raised to a power you multiply, so that would be x to the 12th. All right, 3x to the negative second over 4 to the negative first y cubed. And then this whole thing is raised to the negative third power. All right, so there's no one correct way to do it. So you could flip what's inside the parentheses first and make it positive, or you can flip the whole thing and make the exponent on the outside positive, and I think that's what I'll do. All right, so this will be 4 to the negative first y cubed over 3x to the negative second, and now this whole thing is to the positive third. So when I did the first flip, I didn't change anything inside. I only did that to change the negative exponent outside. So now I'm going to go in and flip what's negative inside to make it positive. So this will come up and this will come down. The y cubed and the 3 will stay where it is. All right, so now that'll be x to the second in the numerator, y cubed over 3 will stay where it is, and I'll bring down 4. Now that's to the positive first power, and then this is being cubed. So now I have a power raised to a power. So 2 to the third power, that'll be x to the 6th, y to the 9th, over 3 times 4 is 12. And then I'm going to raise that to the third power. Well, what is 12 to the third power? Let's see. 12 to the third power is 1728. Okay. And let's try one more. 4m to the negative third power over 3m to the negative fourth power. So first I can flip both of these to change the exponent on the outside to positive. So 3m to the positive fourth power, 4m to the positive third power. Then everything inside the parentheses needs to be raised to the fourth power in the numerator and to the third power in the denominator. So 3 to the fourth power is 81, m to the fourth, and 4 to the third power is 64, m to the third, and I have to take care of these m's here and use the quotient rule. So that would be m to the fourth minus m to the third would just be m. So 81 m over 64.